Hello, here we have a dataset that follows the normal distribution. How do we know that it follows the normal distribution? Well, we can insert a scatter plot and check. The scatter plot clearly shows that the data follows a normal distribution. The formula for normal distribution is given here: exponential minus half x minus mu over sigma whole square. This distribution is characterized by two parameters, mu and sigma. Mu is mean and sigma is standard deviation. Since we do not know mean and standard deviation for this dataset, we can just set the values for both of them as 1 for now, and we will change these later accordingly. Using these values and this formula, we can find or approximate values of y for given values of x. We'll get x from column A, subtract mean from here, divide the standard deviation and square the whole thing. Right, so the reason that we are getting error over here is because the values of mean and standard deviation have not been set as constant for the whole column. We can do that by inserting dollar signs in between the letters and numbers. Now we get a proper approximated data set. Let us just graph this and see how good of a fit it is. As you can see, the fit is quite terrible. The red line is completely off the chart. The reason is that the values of mean and standard deviation must be off, and we need to set them accordingly. To do so manually would be tedious, so we will instead employ sidebars. We can get sidebars from the developer tab from here. We'll just copy and paste to have one for standard deviation. Using format control, we can assign the cell for mean to the sidebar 1. And we'll do the same for the second one and standard deviation. Now we can set different values for mean and standard deviation using the sidebar. Now the means look quite close within the chart, and so do the endpoints, but the middle is quite off. The reason is that there's a difference in scaling. The maximum of both the graphs are quite different. We can make them come closer by using a factor in front of the exponential. Since we want to make the red line smaller, we will put a factor smaller than 1. Let us just put 0.1 for now, and let's see. Okay, so it got better, but it's now smaller than the blue line, and let us just put 0.15 and see what happens. It's much better now, but still, let's go one step further at 0.16. Okay, now the maximum points meet. The curve still isn't a perfect fit, and we can see that the standard deviation of 2 is too little and 3 is too big. So what we will try to do is we will link this to another cell here. The reason we are doing this is because Excel does not allow incremental changes of non-integer values. So if you want to have values of say 3.1 or 0.4, we can do that using the slide bar, but we can do it indirectly by having a cell controlled by the slide bar and dividing it by 10 in another cell or some other value. So let us get to 2. This is what we had before. We can increase this further until we get a good fit. At 2.5 the fit is absolutely perfect. So in this way we have found the mean and the standard deviation of the data that we had, and we have proven that it actually follows the normal distribution. We can do this for any dataset we have. We can check if it does follow the normal distribution or it doesn't, and we can find the mean and the standard deviation of the dataset by fitting a curve. Thank you for watching.